Given a string, how can we tell if that string is a palindrome? So the first step to understanding this question is asking ourselves, what even is a palindrome? So I've drawn out a few examples, but basically a palindrome is any string where the characters forwards are the same as backwards. So this is probably the most obvious example, but MOM, if we spell it backwards, MOM, yes, that's a palindrome. Here, this also counts as a palindrome because for the sake of this question, we're gonna ignore all non-alphabetical characters. So here the 1, 2, 3 doesn't matter. And we're also gonna avoid cases. So even though this is uppercase, this is lowercase, if you do it in reverse, it's still HI, skip these, IH, or HI, skip these 3, IH. So this also counts to palindrome. And this is almost a palindrome, but if we spell it in reverse, we get rack, car, but almost, I guess. So I think the two-step solution to solving this problem is one, we want to clean our string of any non-alphabetical characters and also convert anything that's uppercase to lowercase. So that would be step one. And then step two would be to iterate through our new string with one pointer on the left side and one pointer on the right, and we're going to keep comparing because we know in this new string we only have everything in lowercase and only characters with no spaces, so we know that these indices are going to match up perfectly. So if I were to try to draw out pseudocode, we're gonna need a few standard library functions. So the main one is we need string length because while we're iterating through the string, we want to know how big the string is. And we're also gonna need a function which tells us if a character is alphabetical. And in C++ or in C, you can use the CC type header file, which has an isAlpha function, a Boolean function, which tells you if a character is alphabetical. So that's going to be very helpful here. Also in C++, if you use the string standard library, there is a string length function. And we also want to use the toLower function in the CC type library as well because we want to convert all of our characters to lower if they're upper. So we can call this is palindrome. And we can make this a Boolean function. So first, I think it's a good idea to build a new string that is really a clean version of your original string. So and then for each character, which is in our original string, we're gonna want to add the character only if it's alphabetical, and we also want to convert it to lowercase. So it would really look like is alpha for C, and then if it is, we add it to our new string, but we're only going to add the lowercase. So this will iterate through. So if we take this as our example, once we get past this loop entirely, new S is going to be equal to HIIH. So now that we're at this point, we're going to want to execute our second part of the solution, which is getting two character pointers and keep comparing them. So we can call this one start equals to new string of 0. I'm kind of using C++ pseudocode, but you can stay with me. And our end will be I hope you can see that, but our end is gonna be our string length minus 1. And then we're gonna say while our start pointer is less than our end pointer, if start, and we want to dereference, is not equal to end dereferenced, we're going to want to return a 0, because in that case we know that our two characters don't line up, so our string can't be a palindrome. But if not, we're going to want to increment the start pointer to the right and the end pointer to the left, because really they want to meet in the middle, because you're scanning the start pointer from left to right and the end pointer from right to left. So if we take HIIH as our example, we're going to start with our start pointer on this H and our end pointer at this H, and we're going to say if these aren't equal, but here they are equal, forgot that, we're going to increment our start and decrement our end. So now we're at the two i's, which these two i's are still equal, so we're going to skip this. And then we're going to increment our start, decrement our end again, so now these two swap. But we have hit our condition, so our loop is no longer going to execute, and from there we know our string is a palindrome at this point, so we can return A1, or return true, because we've reached our goal. So for this solution, it would be an O of n time complexity, because you have to iterate through each character of our original string, where n is the number of characters. And it would also be an O of n space complexity, because when we build our new string, we are adding every character that is alphabetical and we're converting them to lowercase. So the amount of memory scales with the amount of characters in our string. Okay, given the head of a singly linked list, how can we create a function which takes this linked list and then returns a new linked list, which is the reverse? So this is really a question about pointer manipulation. So originally my thought process was that we're gonna need at least 2 pointers here, because if you have, while you're traversing through the list, you're gonna need access to the current node and the previous node. Because really what we're doing here is we're reassigning the next pointer of the current to point back to the previous. So if we want to work that out, I'm not sure you can see, but so really what we want to do is keep track of the previous node with a pointer, and then keep track of the current node with a different pointer, and then we want to re-point the current node's next pointer to instead point in the reverse direction. However, you might see that there's kind of a problem here. Now we don't have access to this 5, so instead of 2 pointers, we're actually going to use 3 pointers. So we're going to start with a previous node, a current node, and a next node. This way, when we reassign 4's pointer to 3, we still have access to the 5. So it'll look something like, and then we can either do this iteratively or recursively. I'm gonna opt to do it iteratively simply to save memory space. But if we were doing it iteratively, we would increment all of these pointers. So the previous would now become 4. The 5 would be our current, and 5's null pointer, because it's the end of the list, would be our next. So here we basically do the same thing. We reassign 5 to 4, and then we increment all the pointers again. So this is kind of our stop condition. Once current becomes a null pointer, that's how we know to stop. But once we get to this place, and also I did skip a step, but when you start, you're gonna wanna have previous as a null pointer, so that way you could reverse the first node's next pointer to become a null pointer. So if I were to draw that out, previous would be a null pointer, current would be right here, and our next pointer would be at 4. So we're going to reassign our current pointer's next value to be previous, which is null. So, and this will be our first step of the process. So, but going back to the end when current is a null pointer, once we reach that, that's really our stop condition because that's how we know we've reached the end of our original list. So here we're going to want to reassign the head of the linked list to whatever previous is, because since current is this null pointer, we know previous has to be the first node in the list. So that's how you reverse a linked list. It would be an O of n space because you have to traverse through each node once, but it would be an O of 1 space complexity because you're using just 3 pointers here, which is nice. If you opt to do it recursively, it does have an O of n space, but I prefer to do it iteratively.